So let's move on to some other applications of beam splitters. So one of these applications is the Hong-ou-Mandel effect. This is an effect which basically can demonstrate that you have two photons that are indistinguishable. So what happens in this effect, you would have some beam splitter, and you have one photon entering into one port and another photon entering into another port. And when these two photons are indistinguishable, they will always either exit as two photons out of one of the ports or exit as two photons out of the other port. So they will never exit individually out of the two separate ports. So this is something that can be observed experimentally, but we can also actually predict that this is going to happen using the operator formalism for the beam splitter from earlier. And you can basically work through the math, but you can basically see that in the end, you either would get this you get a quantum state that either contains two of the beam splitters entering out of one port and zero beam splitters entering out of the other port, or zero beam splitters entering out of one port and two beam splitters entering out of the other port. So this is how we can see that two identical photons that are exiting out of a 50-50 beam splitter are going to always bunch when they exit.